Hey everyone, Lazy Ben. Let's get some stuff sorted out. Okay. Let's look at the notes. So, where did we do last week? Optimized pathfinding, allowing PCs to travel on the monorail. That took pretty much all week. So these two are going to get passed over to this week. Author behavior trees in the editor. Okay. Week 11. So we're in the 5th of May, or well, it was a bank holiday, wasn't it? We'll say the 5th of May to the 9th of May. Goals for this week are author behavior trees in the editor. So we're going to author behavior trees in the editor, and then we're going to compile behavior trees into the game data, and then load behavior trees into the game. 3 things this week. We'll leave the bugs. There's still a few bugs to do, but we'll leave it for now. They're not bad bugs. Back end of last week, we just worked on fixing bugs, so we didn't do anything new. But today, the plan is to start a brand new system. Channel. This is the wrong one. Give me a second. I just need to. There we go. I just need to upload some stuff to YouTube. Okay. So we need to upload this one. This is AI2. This one, AI3. This one, AI4. This one, can't export that one. Oh, that's the broadcasting. Nice one. Okay, so the plan for today is to start AI behavior trees. On Jenny. Or for any NPC, really. Okay. Let's have a look. So the first thing we want to do is probably launch straight into the editor. I'm going to be working in the editor for a while. Not the game. To see if that launches straight into the editor. But doesn't load any rooms or anything. Yeah. Cool. So that's the editor. So we basically need, if I look at the engine folder, where are we? Oh, that's annoying. It's duplicated the folder layout. Why does it do stuff like that? So, levels. So the template one we want is behavior. Is that how we spell behavior? Yes. Do we want to call it behavior, or do we want to call it AI or something? AI is such a tainted word now. Brain. Call it brain. Or brains. We're going to make NPC behavior trees. Brains. Oh, Brian's. Brains. Okay, so patrol has patrol base in it. Probably because they're in groups. Quest base. So I wonder if you should do brain base. Brain base. Put that in the template as well. Ooh, right. Brain base. All right. So go to, I haven't done editor work for ages. Any new editors? Editor window. different types of editors. So we're going to base it probably off the Patrol editor because that's the most similar thing. They're eventually going to be linked to the Patrol editor somehow. So it should, derives off inode editor. Okay, so that's going to be our reference. So put it in tools, brain editor. Oops. So we'll do BM delete copy move. Brain editor. And then we want brain editor. So it needs to come off inode editor. Probably need to include it inode editor. So inode editor, BM name, brain editor. So there's lots of overrides. The question is, do we need to override them? I'm going to say no for now. And then we need to include the brain editor. And we'll just see if this compiles. This will tell us if we need to override anything. Okay. We do not, which is good. So we're going to say else if path as extension path dot brain p new editor equals new brain editor. So that's on open. What about new? So it creates it and calls open. Okay. So let's just see if we can create a brain editor window. Okay, so cannot instantiate an abstract class. So brain editor does need to have some things filled in for it. So I'm pretty sure this is meant to tell me we have create method implement interface or something. Is it here? No, here. Implement pure virtual. Is that correct? Create node type from hash. From type hash. Only one. And that will do. We'll just say, just return that like that. We'll eventually fill out what that does. Okay, so let's see if we can make one of these. So if I do new boat brains, brain base, and we're going to just call this Jenny.brain. Right, this is Jenny's brain. Let's have a quick look at the file that it made. I'm in a template now. Jenny.brain. Open with Notepad. So it gives it an asset ID, an asset name, and then there's no nodes. Great. It doesn't actually give it a version, which is the first thing we need to do. Something in that. Levels, brains, brain based, Jenny. So we need to give it a version there, because if you look at cutscene, it's got cutscene editor version 1. So first things first, let's append that to the quick access. How do we do that? Pin to start. Pin to quick access. Brain base. Right, so the first thing we need to do is when we make one of these, we need to give it a version, which is probably in get file header. It is. So this is wstring view get file header. So we're just going to return brain editor v1. And there's another one, save dialog info. So that's save open dialog info, get save open dialog info. This is override. This is override. So I'm just going to return this. This is brains, brain files, brain. All right, so let's make a new one of these and see if the editor, see if the version gets put in the file now. A new, but brain base, Jenny.brain, replace. And then we will brain base didn't get put in. Maybe it didn't. Delete over it. Let's try again. Didn't write over it, I mean. New brain base Jenny.brain. Okay, so it's still not giving it the version. Why is it not giving it the version? very confusing. Didn't even ask for the version. Okay, so let's just check what's going on here. Gone to the wrong one. Role editor it works for. Let's just try and create a new patrol. So let's do new patrols, patrol based, desktop patrol. What's going on there then? Brand. B table just seems wrong. Just going for I editor. Okay, well, let's rebuild this. For some reason we have the wrong V table. Weird. So I'm going to base this on a behavior tree. Oops. So these have got names. These nodes. So we have sequences. Sequences, fallback, parallel, decorator. Parallel nodes will execute all the children in parallel. Parallel nodes will execute all their children in parallel. This is in quotes because it's not true parallelism. Each child node will individually tick in order. Success when at least m child nodes between 1 and n have succeeded, and failure when all have failed. Sequence is all have to succeed. So they call them composite nodes here. And they select what type of node it is. What type of composite node? Sequence selector. I prefer this than the parallel name. Selector. Alright, anyway. To the task at hand. So let's just do any.brain. See if this V table is correct now. Yes, it is correct now. File header. Yeah, that was weird, man. That was Visual Studio being silly. There we go. So we've got a version now. Brain editor. Okay, so right now, if I right click, I just get this little context menu. We need to be able to make these nodes. So if we look at how Patrol Editor does this, it has a patrol node, which is what every node has in common. And then each patrol node is specialized into different nodes. So I think we should just follow that really. Okay. And that derives off inode. So struct I brain node inode. So I brain node const w string view title, and we're passing in a type there. I suppose that's fine. Float width, float height, float color, color. We may as well just do const float color, color. And then that's just inode title type hash width height color. Okay, so that's all we'll do for now for that. And then we'll do struct root brain node I brain node. So root brain node is I brain node root hash code root brain node 65 get editor colors blue. Okay, let's just see if that builds. No. So where's get editor colors come from? Editor colors. That builds. Yes, that builds. So I think that's all we kind of need. So for a root node. Now then, when we have this create node from type hash thing, for each type in patrol node types. Okay, so we need to actually make a list of these using brain node types. Standard tuple. Root brain node for now. And then here could do static inline as well in there. Brain node types. Brain node types. So create root node from. So it's weak pointer inode result for each type brain node types. AutoX using T equals standard decay KT of decal type X. If hash code T is type hash, result equals create node T. And then we will put this assert here. That's the node not been added to brain node types. Right then. And then what we also want is this tick board context menu. We're going to do menu, draw separator, add nodes. If menu draw menu item root node, create node, root brain node. Okay, so now let's just see if we can make brain nodes. Oh, it went down the wrong way there. Okay. So let's just see if we can make a brain node, a root brain node now. So we'll open back up the brain. Add nodes, root node. There we go. So there's our root brain node. And let's save it and we'll just have a quick look. Again. Brain base. Yeah, then. There we go. So let's just launch immediately into this now. We don't have to keep loading it back up again. So this is brains Jenny brain base Jenny.brain. Okay, there we go. So we need another one. So we need a composite node. Question is, do we have a composite node and then have some kind of drop down box which tells you what type of composite node it is? I don't know if you really need to do that. Random selectors sequence. So what I think we'll do is we'll just call it a selector node. A sequence node. So let's make struct selector node, my brain node. yellow. Let's make a sequence node. We'll make them purple, and then we want, what have they called them here? So you've got things called like decorator nodes. I think what we'll do is we will not do decorator nodes yet. You've got things called leaf nodes. Leaf nodes is very generic. I'm going to call it an action node. It's going to be green. Okay. So selector node, sequence node, action node. And then on the context menu here, selector node, sequence node, action node. Okay, so let's just build up one of these trees now. So no, we don't want a complicated one. So we'll go to a sequence. We'll do action. We'll do selector. We'll do it this. We'll make it. Action. 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 All right, and that will be my node tree. So sequence, we probably want to give each node a description, I would say. So we'll start with that. So if you look at iPatrol node, it has a description in it. So look at iBrain node, put that in. W string description. Description. Now we get onto this, how we serialize these things. Tick node panel, which draws the text box for description. So void tick node panel node editor, override. And just say editor canvas and that just does canvas, whoops, raw text box, description, text box flags, compact, and then it calls a tick node panel to the root. Tick node panel, sorry, not to the root. Tick node panel as a patrol editor. This one. So we could do that as well. Brain editor. Editor canvas. Tick node panel collapsed. Do that as well. What does this do? It's literally the same. Apart from its brain editor. We need to forward declare brain editor. Canvas, and then editor as well. Okay. Let's see. We'll see what this looks like now. Alright, so they've all got descriptions in, so we can just say like test patrol. What we want to do as well is save these descriptions. So write and then node. So we got write text, read text. Okay. So all these need implementing. Writer dot write. It's writer description. Yeah, nearly. Description. And then it's node on write text. read text, reader, description, return, node, read text, reader, write binary, writer.write, description, node on write binary, writer, read binary, auto result equals reader.read description, if result equals eRead result, okay, result equals on node read binary, node on read binary, sorry, reader, return the result. All right, so let's see if we can save these descriptions now. So if you just do like the test brain, save that. Let me have a quick look at the file. Description, test brain. There it is. So let's have a quick look at what these actually are. Selectors, so sequences. If one fails, everything fails. So if this fails, it returns fail. Selector. Selector will return a success if any of its children succeed and not process any further children. So it's basically like that failed, that succeeded. There we go, we return success. If they all fail, we return. Okay. Straightforward. So you can have different types of sequences. We can have like consecutive or random, maybe. Right, so let's put in a different, so we can have different types of sequences. Just move this back over here. That means we need to start putting in the actual you know, game brains game. So I'm going to call this game brains .h. And then we're going to have enum class e sequence type, and we're going to have probably not. Well, consecutive. Check that's how that is spelled. Yeah. So we're going to have unknown. Well, no, we'll have consecutive will be the default, right? And then we're going to have random. And then we can just put in, you know, different ones if we want to. So now we have it. I must say that's a U32. So now in the brain editor, we can include GameBrains. We can have in the sequence node eSequence type. So it's consecutive to start with, right? So this needs to get saved. So we want these two. No. We want them. And that. We do actually want to implement these. On write text writer. Reader. They're not virtual. They are. We're just going to say stick all them in. I'm going to do writer sequence type. Sequence type. Return reader sequence type. I'm just going to do writer.write sequence type. Let's return reader read sequence type. Check that builds. Okay, so now we need to be able to select the sequence type. So we want void tick left panel, and then we want virtual void tick left panel brain editor. Like that. And I'll tick left panel is going to do it's called tick left panel brain editor canvas for now. That's all it's going to do for now. That builds. And then sequence node is gonna have void tick left panel override. And then it's gonna do canvas draw combo box type sequence type. All right. So let's just see if we can set the sequence type and save it and load it. So we've got a sequence and it has it there. Type consecutive random. Save it, and if you undo redo works. Let's have a quick look at the file. Sequence type random. So let's see if we can load that back up again. It says it's random, so I think we should also say here that it's a random one. Which means we need to draw on the node itself, which is tick node panel. All we're going to do is we're just going to go canvas draw label. The text is going to be enum name for the sequence type. The color, we'll do get editor colors white. Size we'll just do small. Okay, so let's just see if the node says on it what sequence type it is. It does not. Tick node panel is not even being called. I'm not even call it. So we want to go tick node panel, brain editor, canvas. I say it's a random sequence now, and then if we change it to consecutive, it's a consecutive sequence. Good. Selector, maybe the same. I mean, they haven't specifically said that. Maybe it should be the same. Maybe we should have a consecutive or random selector. If we're ever going to need that, may as well put it in. Enum class is selector type consecutive random. All right. basically the same as this. Selector type equals selector type consecutive. And all these are basically the same. Let's just put these down here. Tick left panel, draw a combo box for the selector type. And then right node text, it's going to be selector type again. Node read text. Right binary. Read binary. Alright, so let's just check we can. Let's just check we can set the selector type. So it's a consecutive selector or it's a random selector. Save that. Load that. All right, cool. So on the patrols, do we say, what do we say? We say it's who the patrol belongs to. So we give it a title. So we don't say who the patrol belongs to, so it must infer that from the title. Maybe. Does it really do that? It can't do that. How does it infer who the patrol belongs to? We don't specifically say. I mean, it'd be nice, but we will put a title in as well. Let's have a look at game patrols. Let's get rid of all these for now. Patrol.get NPC ID. Patrol NPC ID. Default patrol generator. Editor, node loader editor, NPC ID. So it is reading it. It is reading what NPC is. Maybe. patrol editor, NPC ID. Ooh, I wonder actually if it's... If no node is collected, yeah. So if no node is selected, yeah, that's right. It's who the patrol belongs to. So we need to do this as well for the brain. We need to say who the brain belongs to. Now, actually, do we want to do that because we're assigning these brains through the patrol? I don't think we actually do want to do that. So what I'll do so patrols aren't assigned to NPCs. They're assigned. So we might call this something like test. We assign brains through the patrol editor. So we can have one brain can be assigned to many NPCs. Because it's trying to load Jenny brain again. It's not correct. So if we go to editor window, we actually want to load the test brain. So this is the test brain. So we do want to actually set a title for the root. So we'll do that now. So if we look at the patrol editor again, we can see that the root has a patrol route which has the title in it. Okay. So it's bundled it into something it can serialize for later, because this works in the patrol system itself. So we might do that as well with the brains. So rather than putting a selector type there, we're going to do game brains, and we're going to do struct sequence or behavior sequence. And then that's going to be eSequence type like that. And then we say specifically how to serialize them. Okay, so and then we do this for a behavior sequence. And then we just have type sequence.type. And then we want to do this for selector. And then in the brain editor, now we want behavior selector. Then we want behavior sequence. And then this is selector. This is selector. Oh no. This is type selector. Type selector. And the sequence, this is selector, not type. So this is sequence dot type. This is sequence. These are all sequence. So this data file is going to be wrong. So get rid of that. Get rid of that. See if we can still load this back up again. Right. So we'll turn them both to random. Save, and we'll just look at the file again. So it says selector, behavior selector, type random. And it says sequence, behavior sequence, type random. So let's just load this back up and check it works. All loads. So that means in game brains, we need a root struct behavior root. Can't type this morning. Behavior root, and then we're just gonna have W string title. So let's have a look at patrol. Yeah, W string for title. So that is gonna have, needs to be serialized. So we may as well just copy all this. Behavior root. And we're just gonna have a root title for now. Okay. So in the behavior editor now, or the brain editor, the root node can have behavior root. Check that is definitely how you spell behavior. Yes. Okay. So let's stick these in. Not the actual tick node panel. Tick left panel. So this is just going to have canvas, draw text box, title, root dot title, node on write text, writer title, no, root, root, that's it. Return reader root writer dot write root reader dot read root. Okie dokes. So that should allow us to assign a title to this root node tree, to this node tree. I'm not going to display it yet, but we can assign it. So we can go root, and we can say this is a test. We can save that here. And then now we want to be able to see it. So into patrol editor, right? Got this thing called tick board panel. This is it. Void tick board panel. So which one was it? It's the patrol editor version, not the inode editor version. It's the brain editor version. And that's basically it. Tick board panel did not override any base class. Okay. So that must be part of this then. Okay. Part of the... We'll put it here. Part of the base. Control editor, it's brain editor. Okay. This is a test. Two. Cool. Alright, so we can build these trees now. We don't see the title there. What happens on the game patrols? Okay, so there's a collapsed version. Tick board panel collapsed as well. So what does the patrol editor do on the collapsed version? It adds a tooltip with a description. Drops the events icon there. We could definitely add a tooltip. Definitely add a tooltip for the description. That would be good. And it takes the collapsed version. Which just does this. So the collapsed version on the root node. The root node. That just draws it a little bit smaller, I think. Okay, so if you do this, yeah, it goes on smaller. Do we have any descriptions? If I put that over it, it says hello. Brill. So that seems good. Now we need to determine what these actions do. Let's check this in. So the actions are just going to basically refer to hooks into the game code. Right. How are we going to do this? So this is the most difficult bit for the editor work. We basically need to have a drop-down box or something of what action so in Game Patrol, or is it just Patrol? Or is it? It's an NPC, isn't it? We have this thing called NPC activities. And the game must report that. So it goes get NPC activity name for the activity ID. That seems the best way to do it, to give it an ID rather than select the activity. Doesn't really matter. So I'm wondering if this patrol needs to be assigned to, like, hooked into a game patrol. So we can link them in code. Yeah, I wonder. Yeah, we'll do that. So in the actual game, we're gonna have brain. NPC behavior. Or we could do something like we could just stick it directly in NPC here. So enum class eNPC behavior none. We'll put in like the test behavior. And then game brains. I'll have struct game brain. U32 behavior ID, like that. In the patrol editor, so how do we assign? So we've got NPC ID there. We just put it straight in the patrol editor. Yeah, so we're gonna do brain editor. And we'll have the current behavior ID. Like that. So that needs to get stored. And is it on save? On save and on load, on save and on open. Shows it, which just basically writes this. Yeah, okay. So the brain editor now have to reflect template struct reflect type brain editor string view get type name return brain editor template class layout. layout, brain editor. And we'll just do L behavior ID. E.behavior ID. Like that. And then this needs to be a friend. Then on open and on save. So we need to hook in, undo, and redo as well. Okay, so we actually need all three of these. And then we want push, void, push, undo, redo, current brain. Behavior ID. Actually, let's just not do that. Let's see if it automatically gets done first. So we will actually not include that. On the tick left panel for the patrol editor, if there's no focus node, there's not a focus node, we can actually do a text box for the behavior ID. So it's actually kind of similar to this. Get rid of that. And then this needs to be get behavior name. Get behavior name. Or NPC behavior name. U32 behavior ID. And this needs to say if behavior ID is less than enum count npc behavior auto equals static cast npc behavior ID return w name e. So this is actually get npc behavior name now, behavior ID. All right. Build a undeclared identifier. Okay, so let's see if we can assign the behavior to this tree. Depends if you want to do it as an integer or as a drop-down box. Maybe it should be a drop-down box. Maybe it should be a drop-down box. Just doesn't really matter. Depends how many behaviors there are going to be. Not going to be that many. We can say behavior ID is 1, which is the test behavior. So these actions as well, we need to do it with. Yeah, maybe we do a drop-down box. So that would be something like, let's just check this in, and if we just discard this if we don't want to use it. That would be something like TRA W string view get NPC behavior names, like that. Get name, you see, so animation routines. We'll just do a get name. Isn't a bad way to do it. Rather than an enumeration. So this would be something like struct NPC behavior test W string view get name. Let me just return test. And then to get the, and then we have using NPC behavior types. NPC behavior test. And then we could have NPC behavior types. Get NPC behavior types. Do that, and then we just do TRA W string view result for each type, get NPC behavior types. Result dot add x dot get name. See if that builds. Yeah, I think I'm preferring this more. So let's get rid of that. Behavior ID idea. And then the brain editor doesn't have a behavior ID. D. It just has a W string behavior name. Like that. And this is get game dot get NPC behavior names. How does this is a combo box now. That's the other way around though. Behavior name. Okay. Get names. So what does this want? It wants a span of items. But it's a const span. Okay. Doesn't seem to like that. Right then, let's see if I can set the behavior like this now. It's just going to be called behavior. And then if this works, we'll do a similar thing for all of the action nodes. We can set the action node. Because then, now we have it hooked up to an actual structure. We could do call methods like begin, end. And that also means actually we can get rid of this. Okay, while this is building, I'm just going to have a quick 2-minute break. Okay, good. Let's just see if we can actually select the test behavior now. So behavior, we cannot for some reason do that. Okay. Let's see, we're getting the names. Names is empty for some reason. NPC behavior types. There's one thing in it. Doesn't say what it is though. NPC behavior types. Get name. Test. Oh, we're not even returning the thing. That will be it. Right. Okay, so now we should be able to select the test behavior, save it, and then if we load it, it should still be there. Yeah, cool. So we're going to do the same for actions as well. So we're going to have struct NPC behavior action test. We really want to call it test again. It's fine. A test action, we'll call it. And that's W string view. Get name. Const. And then we'll do using NPC behavior action types standard tuple NPC behavior action test action. And we want to get all the types. And then in the game, want TRA W string view get NPC behavior action names. Which is the same as this. Except it's forget NPC behavior action types instead. Right. So in each action we need to be able to select what action type it is. So these things might have initial parameters as well. Might have like state we need to set via the editor. Maybe we should handle that first before we get onto the actions. So the way we'd normally done that is game UI renderer. Oh. UI game event renderer. And UI game condition renderer. These get set somewhere. Here, undraw game undraw path type, UI game path renderer. Yeah, maybe we should do something like this. So the brain has a game brain has behavior ID. And then in the brain editor, we have behavior name now. Yeah. So maybe we need storage for it. So this becomes like a game brain. Yeah, Brian. That's the brain, right? And that has the behavior name in it. Right. And then we need to be able to reflect this. That. And then this is just brain. E.brain, right? And the left panel, we're just setting, so it's brain dot behavior name right now. And the behavior name will have in it some storage. So it'll have hybrid storage in it. I'll say 32 storage. Now this storage needs to get reflected based on the behavior name. Worry about that later. We'll get this build in and we'll just check that it still works, and then we'll work on reflecting what that storage is. So that storage is going to hold an instance of the NPC behavior, whatever NPC behavior it is. So it doesn't have a get name. Where are we? It's not implemented. So this is just test action. And this is in the game, isn't it? Just double check. Yeah, good. Okay, so we can still set the behavior to be test, right? What we actually want to do is not just set the name to be test. We want to make sure that we create an instance of it. As well. So if result, you want to do something like get game dot set NPC behavior by name, and then we want to pass in just pass in the brain. Ensure NPC behavior. Or we could have get NPC behavior by name. Get NPC behavior, brain.behavior name. Brain dot storage equals behavior. So that make an instance as a result dot new value. Maybe. So it should create NPC behavior. Yeah, we'll try that. We'll try that. So the game needs create NPC behavior. Or we could do something like this. Or your NPC behavior. Maybe that would be better. Save the copy. So B, get game, ensure NPC behavior, brain.behavior name, brain.storage. Okay. So for this, we need to do for each type, get NPC behavior, get NPC behavior types. We're going to say if name equals x.getName, using t equals standard decay decal type of x, we just basically want to go output dot ensure t. I believe. So let's do that. So we're going to do, let's see if we can set one of these test behaviors into storage. We maybe want to do this every frame. We want to check it, do the ensure every frame as well. Maybe. Alright, so if I set it to be test, yeah, so maybe it does need to be ensure. Ensure needs to happen all the time. just to make sure. We are setting storage. Okay. So currently storage is empty. If I do that, storage is set to NPC behavior test. Okay, so let's put some state in this. So we say int x equals 2, right? Then we need to create one of these object UI renderers for it. So we can basically just draw it. Draw X and then be able to set it with the editor. Yeah, might as well just do that now. So we're going to say I think we're going to need this for every single one of these. So when we have one on draw, so we'll do static inline dynamic lambda void editor canvas game brain on draw game brain. Game brain's probably gonna have to get forward declared. And then we do template class func static void on draw game brain. And then in the game here we have UI game path renderer. So let's do UIPC UI. Let's do it here. Struct UI NPC behavior renderer. And it's just this. From its game brain. I'm going to say UI game brain renderer. Well, UI NPC behavior renderer. And I'm going to do const w string view name hybrid storage behavior. Do that. UI NPC behavior renderer. Does that work? Nope. And then we want what's it called? UI object UI renderer. Where was it? Game event types. Draw. Like that. Except this can go in the CPP file. And then this just be's ob dot, this is canvas, draw text box, X. So just test, remember, ob.x. So this needs to go through them. So it needs to go for each type. Get MPC behavior types. If auto data equals behavior dot try unwrap. So we're going to do using t equals standard decay t decal type of x. So if we can unwrap it, we basically have to go UI object UI renderer t draw canvas data. Where's object UI renderer? Where is that? So it doesn't know where it is. Where is it though? It's in object UI renderer. Okay, let's see if it's about it now. Cool. Right, so we just need to call this now. UI MPC behavior renderer. We need to set that. So this is iEditor on draw GameBrain UI NPC behavior renderer. Missing a comma. Okay. I've changed it, haven't we? So it's the name. Change the actual rotor signature of the function. So it's const string view const hybrid storage 32 reference. I think that's it. Yeah. Okay. So now we just need to actually call that callback. So we're just gonna go editor. Well, if on draw GameBrain Draw game brain. Canvas. Brain. Behavior name. Brain. Storage. Private. Make it protected, it's fine. Okay. So let's see if we can actually draw it. We need to serialize them as well. What'll be next? Oh, I want to see if we end up in the actual code where we are drawing the text box for X. There we go. So we have X now, which we can modify the value of. We want to do canvas.draw separator. And then the next thing we need to do is be able to save the value that we put into X. There we go. X is 2, so we can set X to be 4, for example. But we need to save. So game brain needs to get saved here. So what types are these? Read is never even called. Read or write is never even called. So the brain is not getting serialized. Right. So I kind of think we do now need to be able to push and undo redo. So we've got push, undo, redo, current patrol. So void, push, undo, redo, current brain. And this is going to do a similar thing, except it's going to be the brain that it pushes in. Brain. And then the tick left panel is the one which sets that up. Doesn't actually need the editor either. And that will serialize a brain. So at least now we'll be coming into here. Which means we need to basically so return that to the 4. I'm going to write the behavior name. So right. Okay. Quick break and then we'll tackle this. Yeah. So another thing I've thought of actually is that we might not want to always have to implement that. We do have concept to check that exists, I think. There he is. So we can say if const expr I think we can just do that. Yeah, brilliant. That means we don't need to necessarily. We've got nothing. If we've got no arguments to draw, we can just leave that out. Yeah, just leave that out. Yeah, but we do. We want to draw X. Okay. So now we need to serialize. We can do it. We need to serialize. We could do it here. Put it in the path renderer. Wherever it is. We have this thing called game path renderer, path type renderer. We have the serialization stuff here. We can do it here, can't we? Same. Binary write, binary read. We've done storage 64 there. 64 might be better. Oh. Should probably give that an actual type, you know. Doesn't matter. We'll say it's 64. Yeah, we'll give it a type, so we'll say using brain storage equals hybrid storage 64. Give it an actual name. And then left panel. It's here. This is brain storage. Problem with doing that is you cannot forward declare that. So we need game's brains needs to be included here. Whatever, we'll just include it. See if that builds anyway. Doesn't know about Game Brain. Oh, it's Game Brains. How interesting. I don't know if I want to do that because it's got nothing to do with Idea. So this is brain storage. We can include it here. Whoops. NPC needs to know about Game Brains. In the game, we need to actually, in order to serialize this, we need to pass it ensure NPC behavior. Now, I wonder if we should rename that something else. Ensure brain storage. So we're going to rename this ensure brain storage. And then we're going to do we'll do this, we'll do buffer binary write brain storage. And then we're going to do read result binary read brain storage. This is buffer So I wonder why these ones, this is what I'm looking for a reference. I'm wondering why these ones don't take any kind of identifier. Game events, binary write event. So we're going through the events and we're just testing if it is that type of event. Yes, maybe we don't need to do that. Where were we? We were in game. So binary write, it just writes the storage into a buffer. Binary read, how does it do the read? Okay, we'll just follow this and see if it works. So what do? It's buffer, brain storage, but storage rather. And then we want void reflect brain storage. Default layout reader. Wow. Brain storage. Void reflect brain storage again, but with default layout writer. Okay. So let's just stick all them in. Let's try and implement all these. All right, so let's make a new game window. Oof, what's that all about? So binary write event, this is what we're kind of copying. Binary write brain storage. So binary writer. So you got to get something called binary write event. Game event. Also, that has the type hash in it. That's why it's happening like that. Okay. Let's get rid of those then. So it kind of does need a name. Name. I think it needs that. All right. So let's just get rid of all these. So the question is now, where do we want to put this? UI NPC behavior renderer. So in the path renderer, we have all this stuff. It's these, isn't it, that we need? I think that is const. And should be called binary write NPC behavior. Binary read NPC behavior. Okay, so in game, this is UI NPC behavior renderer, binary write NPC behavior. Doesn't return a buffer. Writes it directly into the writer. So we need to make our own writer. So writer, name, storage. Return, writer, move to buffer. And then the reader is that. Doing a read. Yeah, binary read NPC behavior. Reader name storage. That builds. Okay. And then the reflect. Okay, so we basically need NPC behavior test. And then we need an actual a reflect. Do it here. This is just L X X. Okay. And then the path one, what did that do? It's called reflect. It's called internal. Right. Right. So this is reflect NPC behavior. These two. Bitwielder, hey, how's it going? Welcome back. It's working on the editor part of NPC behaviors. Not that great. Oh, sorry, man. Yeah, sorry to hear about that. Oh no. Right at the start of summer. I hate that when you catch a cold right at the start of summer. Go through all winter and you're alright, and then at the beginning of summer. Okay, so it's the layout. Layout. Void. Static void. Reflect NPC behavior. Internal. Layout. L. And then these two. Yeah, I'm working on NPC AI now onto a brand new thing. For each type, get NPC behavior types. If x.get name equals name, no, we don't need to do that actually. Yeah, we do. To KT tackle type X. So far this year, touch wood, I've avoided calls and things. And then we need to do behavior to ensure T. We do a thing called hybrid storage serializer. Is that? Yeah, no, it's not that. That's the next thing. Is it just L? Hey, how's it going? Okay, no problem. I'll do that after the stream. Got any questions, just ask, no problem. If you want to join my Discord, I think there's a link on my Twitch page. That isn't actually how it's gone. That isn't going to work like that. How does this work? Just like that. So we try and wrap it, and then we do L of the data. Are we ensuring it exists? Yes. So we ensure it exists, then we unwrap it, and then we put it in. So yeah, that was right. What I did there. What was it? Behavior to ensure T if auto data equals behavior to try unwrap T L data. So, right, I'll do that. I'll reflect that. So we just do reflect internal reader name behavior, and then here we do reflect internal writer name behavior. And then this one does ensure and then tries to unwrap it again. Okay, it's the same. So it's the same thing basically, except it's writer dot write data. This is eRead result equals reader dot read return result. What's the problem? This is const. So it's definitely not const. I have a feeling though binary write MPC behavior. I'm gonna have to do a const cast there. I have a feeling. Yeah, we'll take the consts off there. Nope. is it const or not? I don't think so. Binary right. Oh, I took it off the wrong one. This is the one where it has the problem. Binary read. So write is const. Read is not const, I believe. But does it say that ensure? Yeah, so it's going to modify it with ensure. So neither of them const. Okay. Bit of a mouthful, that code. Let's see what happens anyway. So the game brain now. Well, let's have a look at the game first. So this has to do UI NPC behavior renderer, reflect NPC behavior, reader name, storage. Basically the same for each one, except that's writer, of course. Okay. So basically we need to, all these need to be called somewhere. So in game brain, now we need to do that, and then we need to do get game. Well, this is just get game dot binary write brain storage brain dot behavior name brain dot storage. We may as well just auto buffer. So auto result is that. I'm going to say if result equals eRead result okay. We want to read the buffer. Reader.read well, we'll do this, we'll read that and then we'll read the buffer in. If the read result is okay, we want to do get game dot binary read brain storage brain dot behavior name buffer brain storage, and that returns in a result as well. We return the result. All right. And then we need to do if constexpr standard is same layout, default layout writer, get game dot reflect brain storage. Well, there's a writer or a reader actually, so we could just do this. L brain behavior name brain or storage. Right. Let's build that. Fix any compile errors, which they are immediately compile errors. So we need to include the game here. That's a bit dodgy. We'll try. Game not found, it says. See an app. Not in game. App is okay. No. Really? No, it is in game. So why cannot you find it? Because game probably includes game brains. So this is the problem. So we basically need buffer right brain to buffer game brain. Hey, how's it going, Programmer Jeff? Yeah, no problem, mate. Okay, so write to buffer is this. Write brain to buffer brain. And that just does that. include game here. And then we want read brain from buffer. Buffer. Game brain. Results. Output. So this is read brain from buffer brain. Okay, and that just returns that. Hey, how's it going? Wow, look at this. Thanks for the raid. Hello. Working on a new thing for the engine. Thanks for the follow. Working on a new thing for the engine, which is a NPC behavior. So I'm going to be able to draw these graphs out. See if I can build it. I don't know if it's able to build yet. See if I'll show you. Thanks for all the follows, guys. Reindeer Flow, Mixtor Studio, Bags, thank you very much. Mr. Zombie UK. This is great, thanks guys. Let's see if I can find a build that works, and I'll show you. Unfortunately not. That's a shame. But yeah, the game's like a sci-fi gardening game, or it's going to be, where you're on a space station and you're in control of all of the gardens on the space station. And you just go around and you plant plants. Quite a chill game, really. There we go. Cool. So what I'm working on now is behaviors. So this is the part of the editor of the engine, and you author these. You attach this to like an NPC, and it goes through this graph, and these actions are like you make the NPC decide to do something. So this is Jenny, the NPC, and right now she's on patrol, so she's just walking around. And this is a monorail station, so the space station's going to have a monorail on it. Now, this is very early. I've only been developing the game for like week number 11, I think, at the moment. So the space station's going to have a monorail on it, and all the NPCs and stuff in the game are going to be able to use the monorail to get around the space station. And she like catches the monorail to her next destination or whatever. So if I go and I know where she gets off. This is all kind of standing. There's no real art yet. I'm going to draw that later. You know, probably the next 2 or 3 months I'll start drawing the game. And then she gets off, and then her new target happens to be this pink square here. So she's just like on patrol, walking around. So I'm developing all that now. I'm fleshing all that out so that they'll react. So say like, you know, she was in a cafe, and then you did something like stole something all the NPCs would react, and that's what I'm going for now. That type of thing. But yeah, it's like a full custom editor. So I've like, if I open up the editor in a different room, so you can like, you know, it's got like dynamic light and shadow and reflections, and you know, you can place stuff in the level. What else can you do? You can like draw rivers and stuff. And then it's got like full undo redo. So yeah, I've been working on the game like 10 weeks. But yeah, working on the actual engine for about 18 months, something like that. Better grass density than most AAA games. Yeah, I mean, the grass is good. It reacts to the wind and everything. If it was windy, I don't know if you can see, like, there you go, there's a bit of wind going through. And then so what I've been doing is like prototyping a bunch of stuff. So you can so Sven's going to be like a droid, and he's going to help you do the gardening. So we'll do stuff like you can destroy rocks, and then you can get common resources like iron ore. So the idea is you're going to be able to take the droid down to like asteroids and stuff and planets, and then use Sven to like mine things, and then back on the space station you can, like, you know, remove grass and then plant like an apple seed, and then you use cosmic sludge to fertilize it, and eventually I'll draw all these stages out, you know. Yeah, I mean, I want it to be quite ambitious. I think I'm confident I'll be able to do all this stuff. So eventually, it's an apple tree shoot now, but it'll eventually go to be an apple seed. Gardening in space, yeah. That's what I'm going for. And then this room's like a chest. This room's a shop. So it's all prototypes, basically, of everything. So this is Tim's Seedware, and you can buy apple seeds off him, and you can sell, you know, you can pick stuff, you know, fruit, plants, sell it at the shop. So this is a data charger. So this is to do with crafting. So you get given like locations by NPCs for doing quests, and this is like a radar, and you put data cards in, and then I've got like a hard coded planet there, and then you like tune it in, and then you start receiving messages from Briggs Spaceport. So that's like a space station somewhere else, and it charges these data cards. Thanks for the raid. That's really awesome. Thank you. Really good. Yeah, and you can fill these data cards up, and then you can use them to unlock recipes. So you're like receiving messages from outer space, and they've got cool information in. Then you know, you can unlock these. You get these blueprints, and then you unlock recipes with the blueprint. So you can download the data to the blueprint like that. I'm gonna need some more data. And you can like buy data cards and sell them and stuff like that. So if I put that in there, so the apple seed blueprint, and you download it, and then you can unlock the blueprint, and you get recipes for apple seeds. And then the next one is like, it's like prototypes the crafting. So this is a crafting bench. So you can get the apple seed blueprint and add stuff to a queue, and then you can like craft apple seeds with the dude. You got 3 apple seeds. So yeah, the next thing, what I'm currently working on now is getting the NPCs to like do stuff, you know, react. react with things that you do in the world. Yeah, and it's got fast traveling, so I can go back to that main room. Land right on top of Jenny. Yeah, it's cool. This is really cool, man. It's the first time anyone's ever raided my channel before. If you've got any questions, guys, then just ask. That'll be awesome. It's quite programming heavy stream, really. Yeah. But right now, the particular thing I'm working on right now is just serializing these NPC behaviors to disk, so I can import them into the game later. Thanks for the follow, Roberto. That's awesome, man. I've got like quite a lot of followers there. Thanks, guys. It's really cool. Anyway, back to work. That was exciting. So yeah, I'm working on, I've got these things called game brains, and they're the things that you author in the editor with these graphs, and then you're going to be able to attach them to the NPC patrols. So, you know, when you get to a certain place, you can be able to like attach this brain, and that's how the NPC will behave. So the NPC might behave differently if they were in a bar versus if they were at work. That's kind of the idea. All right. Where was I? Getting this to build. So can't find get game. So that means we need to do void layout members for default layout reader and the brain. And for the writer as well. So we'll do the reader and the writer. Yeah, have a good one. Yeah, games are a lot of work, but I like it like that. I like that there's loads to do. Yeah, let me know what you're working on. I'll check it out. Reindeer Flow, thank you. All right. So title. Programmer Jeff. Oh, cool. Awesome. Fireflies in space. Yeah, after stream, I'll check all this out, man. This is really cool. All right. Oh yeah, cool. So like a proper real-time shader editing application. .3D terrain.
Because we might play Here we go. It's kind of like this. We're gonna change this. Terrain shader, smooth movement. All right, we already got that.
47 minutes. I won't watch all of it if you don't mind. It's 47 minutes, but yeah, I'll check it out. Is this your YouTube channel as well? Oh, Learning OpenGL. Is that you? Cool. Nice one. C++ OpenGL shader code. That's really cool, man. Okay, yeah, nice one. Tell you what, I'll subscribe because get back to where we were. I'll subscribe and check it out. Awesome. Yeah, this is what I'm doing. Behavior trees. Behavior trees for AI. Ah, right, yeah, okay. Yeah, I thought I was going to have issues, a lot of more issues with my computer because it's quite an old computer now, this. I've got this is like 8 or 9 years old, this computer. But it seems to be fine. It seems to be handling it alright. I do need a new computer. Just can't afford it. Unfortunately. Alright. So I'll tell you what we'll do. We won't do that. We will put both of these into the source file, which it doesn't think exists, or it doesn't think it can. But it definitely can. Yeah, Visual Assist is very broken when you do this. And then that can go away. And that's just the same. So this is reader. This is writer. Newegg for computers. And they shipped, is it from the UK? Oh, yeah. It's American. I think it's American. Oh, they have a United Kingdom one. Awesome. Yeah, I mean, I hope to be able to get a new computer, like, maybe after the summer. Depending how busy the summer is, you know. Maybe. Reflect type. Doesn't know about reflect type. Text serialization. Brain, undeclared identifier. This is output. Hey, how's it going? Yeah, that raid was crazy. That's the first time that's ever happened to me. It's really nice. Yeah, I spend a lot of time trying to figure out how I broke things as well. Very common. Abnormalities. It's a cool name. Oh, really? Programmer Jeff, thank you. That was really cool. Yeah, I mean, I've never had more than maybe like 5 people watching me before. So it's crazy. It's like 30 something people. Thanks so much. All right. See if this builds now. You gotta like quickly scramble to show. I wanted to quickly scramble to show my game, and it was not, it was not in a buildable state. All right. So this is one of the problems. This is one of the legacy AI problems. Is this const stuff here? I'm gonna have to const cast this. There. Yeah, man. Oh, thanks for the follow. Abnormalities. Look at that. I met my follower goal with that. I mean, I don't mind only having a few people watch because I'm so new to streaming. I think I would get proper overwhelmed if more people were watching. Like, it was very difficult for me then to be like, look at the chat and trying to figure out how to show my game. And I think you got to kind of slowly build your numbers up so you don't get so overwhelmed. Ooh. Because I've only been streaming for like, since late January, early February. Prepared script, yeah, totally. In case it happens. Like, I knew that I wanted to show the game and explain about the game. I need to have a shortcut on my computer that will immediately launch the game, the last build of the game. That's what I need. Grid map turned sideways, really. Flipped X and Y around, probably. That could be it. Anyway, back to the chill. Turn the music back on. Alright, got a linker error. Hopefully, maybe I fix that. So we have separate layout members functions now. So we need to put breakpoints on there too. So I can check that all this works. Is there a way to automatically get your videos onto YouTube? I know you can manually export them, but I always forget. And then I have to go back and do like 3 videos at once, and then I lose track of like what the order of when I streamed. It'd be good if you could just manually, automatically export everything to YouTube after you'd finished the stream. Alright, fix this linker error. NPC behavior test. Get type name. Looks like it is actually not implemented. Restream. Yeah, I know like really nothing about streaming software. I just got Streamlabs, and it's been okay. But you know, we need to I need to have an explore and see what's the best. Right. Okay, so it's not going to work. Let's just build. I don't want to build here. Twitch is more social based. YouTube more educational. Yeah. I'm definitely going for the more social. I come from like a small town where I don't know anyone. I don't know any other programmers really in my town. So one of the main reasons I'm streaming is to meet more programmers, because talk programming, you know. Yeah, me too. Because I don't work for like a big company, like I don't interact with programmers ever, apart from on Twitch, which is nice. Yeah, man, I've found that, you know, like the game dev community on Twitch has been really good. I haven't had anyone be obnoxious or anything so far. Everyone's been really like into it. Yeah. Oh yeah, I know, as you get bigger there'll inevitably be trolls and stuff, which is fine. But so far, so good. It's one of the perks of being smaller, I think, is less trolls. Alright, let's see if we can get this to work. And then we need to do a similar type for the actions. So what we're doing right now is the NPC behaviors, and then we want to do the NPC actions, behavior actions, similar serialization. Yeah, see you later, programmer Jeff. Thanks for doing the sorting out that raid. That was mint. That. Is it late where you are? Abnormalities. I'm in the northeast UK, so it's only 1:45 in the afternoon at the moment here. 11 PM. Right. So where are you from? Okay, so this is us actually trying to read the brain out of the file, which probably isn't even in the file. Game brain title test. So test, and then we reflect, which is reflect NPC behavior. Reflect internal. So as long as we end up here, which I don't. Yes, we ensure. So we do set it to a test behavior, and then I'm going to read it. To X. There we go. Mint. Oh, I see. Cool. Australia. Yeah, they're over there. Yeah, I've got some family in Australia. Got my whole mum's side of the family. Well, a lot of them. Not all of them, but a lot of them. Live in Victoria. Alright, cool. So if we change this, it should test the binary serialization because it'll put an undo redo state on. Okay. So you missed the right buffer. I think it did work though. There we go, it's doing it again anyway. So storage, NPC behavior test, x equals 3. Right behavior. So it's going to push in x equals 3. Cool. So that works. Let's test the read. So if I press Control Z for undo, it's going to write again the new state, and it's going to read the old one. So what do you do for work? Abnormalities. Finishing at 9. That's pretty late, isn't it? Unless you work, in hospitality or something. So we read the name, which is test. Oh yeah, cool. Yeah, that's long hours, isn't it? And night shifts and all that stuff. So we're just going to set up the reader, and then we're going to read in from the reader. 4 bytes in the reader. X equals 3. Did that even work? Not crashing. X equals 2. Alright, let's just start again. So put 3 in. 2, 3. So it looks like it's possibly putting in 2 undo redo states as well. Four goes back to 2. Yeah, I'm not sure that's working properly. Let's just try and catch it messing up. So if I press Control Z, it goes back to 2. And 3. And 2. I'm doing redo and undo. Press Control Z again. So it pushed 2 states on. That's all that's happened there. And that's probably because of this. We might not need that. I don't know if we did need that in the first place. We do need that. So it pushes it on there. Where's that coming from? So literally that is coming from draw text box. And then it's pushed it on again. Draw text box again. So it's pushed on 2 states there. Oh look, it's got 2. It's actually got 2 listeners. Actually has 2 listeners on it. So it's already got 1 on it. Right. Calling hook undo redo there. Push undo redo nodes. Oh, nice one. Yeah, nice one. Yeah, collision's a big topic. What problems are you having with your collision? Collision's a big thing, big topic. Oops. Okay, so it looks like so that left panel is pushing some undo redo as well, but it's not to do with I mean that just seems like it would be broken. Like a broken way of doing it. Hook undo redo. Canvas on undo redo. Push undo redo nodes. So it needs to get put into this step. Right, okay. Yeah, so your characters may be constantly detecting collision. Yeah, because collision's usually 2 parts. It's the detection and then the response part, and the response usually pushes the character away from the collidable thing. So in the next frame it's not colliding, and then the character can move on. Usually that's how you set those things up, yeah. Well, it needs to be part of this step. So we're pushing an undo redo step there, and then we're pushing an undo redo step there. So we're pushing 2 undo redo steps. So let's just put a breakpoint there. That means does that mean it's broken for the other types of nodes as well? Two events. So the first one is the nodes. It pushes a step. And then the second one is the brain. Yeah, so that's kind of broken. Let's just see if it's broken for the other graph stuff. It might be broken for patrol as well. So if I send that 3, yeah, it probably is, you know. Okay, we need to change how that works, because that's broken. Totally broken, man. We need to be able to hook in to a current undo redo step. So if I do this and this, what happens? Yeah, look, it's put one in. And it didn't actually save it either. So that's not actually working either. Maybe we didn't even we're not even saving it actually. Yeah, okay. I'm gonna fix this. I'm gonna go have a 2-minute break and make a cup of coffee, and then we'll come back and fix this. Right, I'm back. So let's first fix it in this brain case. So in the brain editor, on tick left panel, we don't want to do this. What we want to do is we want to, in the editor, we're going to do like editor on undo redo step, like that. And then push undo redo current brain. It needs to have the step. What's it called? Undo redo step. That's the way it needs to work. This step gets passed in. from the editor, from the node editor, right? So we want an event listener. Evade on undo redo step. And we pat it. It's an undo redo step. Like that. So on undo redo step. So we need to do template class func void on undo redo step func callback, right? Then we should do on undo redo step dot add callback. Right, so let's just see if that works. That compiles. It does. So then when we do this, we need to do so this, unfortunately, is just a lambda. So this is easy. It's on undo redo step first. He's changing this to be an event listener. I don't really want to do that. And we could do that. Difficult one. Yeah, I don't know about that. Change this to be an event listener, but that means changing in a lot of places. So I might rename this to on push undo redo step. And I might have another one on undo redo step. And then that would mean we would have to do that would be add data brain, and then editor on undo redo step. Also, where were we? We just deleted it, didn't we? Step and next. This step, next step. All right. So we've broken it up a bit. So it's 2 calls now instead of 1, which is a shame, but it's fine. And then in the node editor here, we do on do redo step next. Right, so let's just see then if that fixes that problem. Double up, putting two steps in. If that works, we can fix it for the patrol editor. I wonder what happens in the dialogue editor as well. I don't think it has undo redo in that way. It does have undo redo, but just not in the same way as this. Okay, that crashed. So it already contains something called brain. Really? Weird. So the step has in it 7 entries. Then we're going to add the 8th entry. Step to add data brain. And it's coming through again. Ooh, 224. Okay, so we're adding in events loads of times. So this needs to actually happen on an initialize. Actually, oh, that's a shame. Do we have an on initialize? We have after initialize. Okay. So what we need to do is override that. Bool after initialize. And then we put them on there. So let's just check this definitely comes in. All right, so it's definitely getting called. Seems to be getting called twice. No, just once. So now if we do this, we only have one event in there now. So we add it in. Yes. Brilliant. So let's just run this. Oh, well, I've got this thing going on here. What's going on Visual Studio? So it's still getting called. It's getting called twice. Something happening with Visual Studio. I've got this weird no entry sign. No idea what's going on there. Restart Visual Studio. All right. Okay, so I'm going to push this step. There's only one in there. It is pushing 2 steps, but that might be okay. So I'm pressing undo, redo there. It seems to be working, kind of. I think that is working. X is 2, press undo, goes back to 3. So we want to go to 2, then move this graph. Try that. Yeah. That's working. Brill. Right, so we need to do a similar thing with patrols as well. Because that was also broken. Cool. To initialize inode editor. Check that builds. So this push undo redo current patrol, right? We need to basically get rid of that. So we need to do editor on push undo redo step. We'll just do that one. And then editor on undo redo step. Auto step, auto next. We want to do that bit. And then these can go away. All right. I'll just do a quick check that that is fixed as well. It's exactly the same, so it should be fixed. Exactly the same kind of logic. If it will build. Okay, so let's open the patrol up instead. So I want to go MPC 3 and then move this. So it should move this back, deselect it, MPC. Oh, it didn't work. Oh, we're not actually. We're not actually pushing the MPC ID, so that's fine. We can do that. We can push both of these on. Do undo redo. Step add data MPC ID. PCID step.add data. I must just not have included these when I originally wrote this. So that's next.add data. And then step.get data. Okay. Which worth saving those. Alright, let's try again. So we're going to go 2 and then we'll move this over there. Oh, we're in the wrong one actually. Which is a patrol. We need to test. So we're going to go 3. Move that over there. So it moves it back. Deselects it. Puts it back. Yeah, brilliant. It's working. Oh, that was a bug. That bug's been in the engine for ages then if it's with patrols. I mean, it's really subtle. It's just undo redo, so it just pushes an extra undo redo step in. So all you'd have to do is press undo again, and it would have got back. Like one of the undos would have done nothing. That's all the bug was. But it's nice to get it fixed. Anyway, so we were also testing whether we could save this. So press 4 and save. Look at the data file. NPC behavior test 4. So it did work. Brilliant. Let's just see if we can load it back. Right, so we need to do the same for actions, because actions are the same as, they're going to have an action type, and then they're going to have initial conditions and state that you need to set. So an action could be anything. An action could be run away, or it could be fight player, become hostile. In the game anyway. Right now I'm just going to do a test action. So in NPC we do have this NPC behavior test action, and we'll just do a W string str, right, equals ABC. So the goal is to be able to alter this ABC in the editor. We'll make it, we won't do a string because the string needs more work. We'll say float A equals 1. So this is trivially binarily serializable. Now I'll tell you what we'll do. Make it a little more complicated. We'll do enum class e test action type sausage bacon, and we'll do that there, and we'll set it to be sausage. Alright, so this is trivially binary serializable. And then we want to reflect this. And this is type, dot type. And then we also want the UI renderer for it. All this is going to do is canvas, draw combo box, ob, call it type, ob dot type. This is good, right? And then we want a UI NPC behavior action renderer, I think. So basically, I want to just copy this. Now then, what do we actually want to pass here? So I think what we want is using brain action storage, hybrid storage, 64 bytes of storage. Then we're going to do struct game brain action w string name brain action storage. So it's kind of the same. Yeah, so we've called this behavior selector, this behavior action. We've already kind of done this. Behavior action storage. So a behavior action, and then we want to where do we want to store these then? I think we want to store these in the nodes in the editor, the brain editor. Wherever the action node is, we want behavior action. And all these as well. We don't need tick node panel though. Well, maybe we do, because I think we're going to actually write what the action is in the node panel. So tick node panel. We're just going to do editor draw label. No, canvas.draw label. And the label is just going to be the action name. We don't know yet. Oh, we do have its name and storage. So that's just going to be action dot name. Get editor colors white. We'll just draw it small. Tick left panel. So this one, we won't get NPC behavior action names. NPC behavior action names, which we do have already. So auto names equals get game, or get NPC behavior action names. And then we're going to do auto result equals canvas.draw combo box action. And then it's action name names. If result, so if we have a result here means its combo box has been changed. We need to make sure that we set the action to what the person has selected. So it's got this thing called ensure brain storage there. I think what we need is ensure action storage. So I might rename this as well. Get brain action names. Get brain behavior. What's this? Get brain action names. Get brain behavior names. So what I might do is I want bool ensure brain action storage. Const w string view name. What do we call it? Brain action. What do we call it? Behavior action storage. Yeah, maybe it should be better called brain action storage. Behavior action storage. Storage. Not output. Maybe we should call it brain action storage. Behavior action, we've called it. No, it's fine. Okay, so ensure brain storage. It's basically this. Apart from this is bool result equals false. Result equals true. Return result. So it's the same, except we're not looking over the behavior types. We're getting get NPC action types. Right. So in the brain editor now, if there's a result, we need to do get game dot ensure brain action storage action dot name action dot storage. So let's just test that. once it's built. So if this works, we'll just be able to set the action using the editor to the test action. And then once we do the serialization stuff for the action, that's the editor bit done. Check some off the list. Yeah, do these 4 methods, and then we need to do the we need to do the get the action rendering in the editor as well, like the state of the action. Maybe we'll do that now before we test it. So yeah, on draw game brain. We want on draw game brain action, right? And this is a brain action storage. Is that what it's called? Brain storage. It's called behavior action storage. Yeah, it's different. On draw behavior action. Okay. So template class static void on draw behavior action func callback. So this is what we're going to set. We're going to set the behavior action to be called, and then in MPC we have a behavior action renderer. Okay, so this is behavior action storage. Whoops. Actually, I think these should be called behavior action. Oops. See if I do all of it. Did it make them? Did. Put them in a weird place. Apart from it didn't do the void operator one. Void UI MPC behavior action renderer operator. Check that builds. Oh, I've done the wrong one. Whoops. It's a problem. So this is behavior, action renderer. Okay. All right. So this is for each get see behavior action types. I mean, it's the same as which one? The render. It's this one. Except it's NPC behavior action types instead. So that should do the drawing. That should do the drawing of the action in the editor. Right. So in game. Okay. So now we can say editor on draw behavior action UI NPC behavior action renderer. That hooks them together. And now in the brain editor, action node. I think it's behavior action actually. Okay. It's just action.name. Undeclared identifier for that. It's editor dot. Cannot access protected. I see. So what does it need? It needs a canvas, a string view, and a behavior action storage. Called canvas, editor canvas. Behavior action storage. This is just if draw behavior action. Draw behavior action. Canvas name storage. All right. So now we can just call it directly through here. Undraw behavior action. So let's just build that. We'll see if we can set the actions in the editor now. And then we need to fill in these. Gonna have to head off at 3, I think. So 5 minutes or so. Pick up my kid from school. Make good progress today though. We should finish the editor stuff off early tomorrow morning, I would say. And then we can actually get on to implementing some of these actions for proper and behaviors. All right, let's just see then. So if I press the action, we get a little combo box. Test action, type sausage or bacon. Awesome. And it says that is now a test action. This is a test action, bacon. That one's sausage. Brill. All right. So let's just fill in these. Writer. Action. Return. Reader. Action. Writer action. Return. Is it writer.write, I think. Return reader.read. Action. Now it might not be able to build this because it doesn't know how to do it. Oh, it does know how to do it. Right. So if we go to Game Brains, so we need to now put in these reflectors. So that's going to be pretty similar. This is going to be pretty similar to the game brain, except this is going to be behavior action. And the reflection, okay. So those two need to go into the field for two functions, it says. That work? This is reflect type behavior action. Doesn't like that. Well, that one. Wonder why. It worked for one. Nope. Function signature is copied to clipboard. Okay. Copy this. So this is behavior action. This is action. Oops. I think this is just called name. Name. Giving this title for some reason. Right brain action storage. Right behavior action storage. Binary right behavior action storage. Binary read behavior action storage. Reflect behavior action storage. There and there. This is just name. Behavior action storage. All right, so we'll just get this building and I'll have to go. That was my alarm. This is just name. right brain to buffer. Behavior. Action. Right behavior action to buffer. What do we call this? Action. Action's fine. No, we'll call it behavior action. It's better. All right. So I'll just put a little note. This is where we're starting tomorrow. Right, I'm gonna have to go. Raid was awesome. So yeah, I'll see you. I'm streaming tomorrow. Hopefully from about 9:30 GMT all day. All right, see you later, guys.